Students, you are able to hear me? Yes, students, we'll get started. Yes. So today our topic of discussion is probability. Okay. It is, I can say it's a slightly extended version of what you have learned last year. Okay. So according to last year's concept, you people tell me, what do you know about probability? What is the basic idea you people have about probability?
So could you repeat the question?
See, you would have learned this chapter in 10th standard, right?
Yes, sir.
You've learned probability. So what is it? What is the basic idea you already have about this chapter?
Basic idea in the sense like formula, sir. Or
As formula, or what? Why do we use it? What exactly is the output? When do we use it? All those things. Like, okay, if I have to be precise, yes, tell me what is the formula that you people know? Whatever you know, if people tell me, you have learned something like in terms of outcomes. Whether it is right
tossing
or wrong.
a coin, sir.
Tossing of coin is one such scenario. Generally, what is the basic definition of probability? It is number of
Favorable outcomes by total number of outcomes.
Okay, by the total number of outcomes. So, what do you mean by favorable outcomes?
The outcomes we require or which we want.
Okay, so this is the outcome. So, outcome is for what? What are we doing for us to expect something called as an outcome?
There should be an event.
Sorry? You do something called as an experiment, right? Okay, you'll be doing something called as an experiment. So I'll give you another example. Let's say, so last year everybody would have done an experiment of Ohm's law, right?
Yes.
Everybody knows this, right?
Yes, yes.
Whether it is commerce student or science student, you people know. So you did V is equal to IR. So in the experiment that you did, your work is to find what is the value of resistance. Okay. So what you will do is you will have a tabular column. In the tabular column, you will have one of the columns as R. You will be noting down the value of R. So 5.23. Again, 5.23. 5.24. You'll be noting it down like this, right? So what exactly you're doing here is you're doing an experiment. Okay. Now, if I say you have a data in your hand, okay, you have a certain set of data in your hand based on the experimental aspects that you have performed. So 5.23 ohm has come out, 5.23 ohm has come out. Next it is 5.24 ohm. So based on, see, there's a very limited data, that's a different story. Based on this, I'll ask a question. What is the probability of you getting 5.23? What is the probability of you getting 5.23?
2 by 3.
From this, so you told 2 by 3, right? So what does this 2 by 3 actually mean? Out of the 3 times you have performed the experiment till now, you have got the value of 5.23 2 times, right? So that's why you told it as 2 by 3. So that's what is technically called as probability. If I rephrase my statement like this, what is the percentage of your success to get 5.23? What will you say?
2 by 3 into 100.
So it is 2 by 3 into 100. The meaning of this is I have a success rate of 67%. Okay. So what exactly the meaning of probability speaks is about when you do an experiment. Okay. Probability is all about doing an experiment and you keep observing the outputs. Based on the output data that you have, based on the data of outputs that you have in your hand, you will be able to speak about the concept of percentage of success or percentage of failure. Okay. If the word percentage is removed, you will have a fractional value. And that fractional value is what is called as probability. And that is why the definition goes like total number of, number of favorable outcomes divided by total number of outcomes. This favorable here means in favor of what we require. In the example that I gave you, my favor is 5.23. Are you guys able to understand why we are studying probability?
Yes, sir.
Right? So here, what we would have actually missed in our 10th grade is we would have never used the word experiment. There are some technical names that are associated. Okay, like experiment, we call it as event, we call something as sample space, and all those things are there that we are going to see on a technical aspect this year. Okay, and that's what we are going to call it as the classical theory of probability. Shall we start, guys?
Yes, sir.
Now listen. So when I talk about an experiment, I want you all to make a note. All these things that I'm explaining are not there in textbook. So when I talk about an experiment, okay, experiment is basically done to study something, right? So when I talk about an experiment, there are two types of experiment that we have in our hand. One is deterministic, and the second is random experiment. Okay. So I told you already, probability means it's all about studying the outcomes of an experiment and trying to calculate the percentage of success or failure rate. Right? Now understand, guys. What do you mean by a deterministic experiment? So deterministic means something for which you already know the output. For example, so Rohan told me about tossing a coin. So if I ask you what the probability of getting a hit when you toss a coin, what are you going to say?
1/2.
1/2.
Yes. Your answer is 1/2, but my question is ambiguous. I didn't complete one thing. I told you tossing a coin, but I never explained about the nature of the coin. So it is up to me, right? If I take a coin, it is up to me. I can think of designing a coin which has head on both the sides. If suppose there is a coin which is having head on both the sides and I'll toss and I ask you what is the probability of getting a hit, what will you say?
0, sir.
It is 1. Because both sides are head, man. However you are going to toss, you have 100% success rate.
So you asked for tails, right, sir?
I told head only, no? Okay, whatever it is. I remember saying head. Okay, let's say both the sides are made up of heads only and you're tossing a coin. Then what is going to be your output? It is going to be 1. This kind of a coin is called as biased coin because it is fixed on both the sides. It's biased on both the sides. It's having unequal weightage because tail is eliminated. Either I have a 100% success rate or 100% failure rate. So when I toss a coin which is biased, I can say this kind of an experiment is deterministic because I know what is the output. So if I talk about an experiment for which you already know the output and you're performing it, that kind of an experiment is called as deterministic. Now comes an important question. Is probability important or applicable for deterministic experiments? What do you think it is? Is there any use of studying probability for a deterministic experiment for which you already know the output? You know that this is going to happen. What is the concept of studying probability? There is
There are various outputs, then we can use it, sir.
yes. So for a deterministic experiment, we don't need to study probability because you know the output. In the sense, when I say you know the output, you know whether it is 100% success or 100% failure. So what are the values you're going to get? You'll either get a 1 or you will get a 0. You'll not get any value between them. But probability is all about calculating the rate of your success, the percentage of your success. So for that, the experiment that we are going to perform is always a random experiment. So our interest of study will always be a random experiment. Okay. So that's what we are going to see. So random means we don't know what is going to be the output. If suppose I have an unbiased coin where head is on one side and the tail is on the other side. When you toss it, you have 50-50 chances. Right? Similarly, you have a die. If it is unbiased, then each output is possible 1/6 times. You can get 1/6 times. You can get 2 1/6 times. I mean, I'll not say times. There is 1/6. There is a probability of 1/6 for you to get 1, 2, 3, 4, 5, or 6. That's what I'm trying to say. Right? So let me read out certain points. I hope you're able to follow me, right? I hope you're able to understand. Yeah. So in our day-to-day life, we perform many activities which have a fixed result no matter any number of times they are repeated. For example, given a triangle without knowing the 3 angles, we can definitely say that the sum of the measure of the angles is 180 degrees. So we can perform many experimental activities where the result may not be the same. When they're repeated under identical conditions. For example, when a coin is tossed, it may turn up to be a head or a tail, but we are not sure which of these results will actually be obtained. Such experiments are what are called as random. So the experiments for which we don't know what is going to be the output, provided it is being repeated under identical conditions, is called as a random experiment. Guys, is it clear? So an experiment is called as random experiment if it satisfies the following 2 conditions. What is it? It has more than one possible outcome. It is not possible to predict the outcome in advance. If you are able to do so, it is called as a deterministic experiment. Okay. So check whether the experiment of tossing a die is random or not. So the answer, if you have to answer this question, what will you say? So is tossing a die random or deterministic?
Random, sir.
Random provided the die is unbiased. If it is biased, it is deterministic. Okay. So in this chapter, whatever experiment we are trying to refer is always a random experiment unless it is mentioned in the question. So don't worry about it. There is no question of deterministic at all. Okay. So when you perform an experiment, you get something called as an output. That's what we call it as an outcome of an experiment. Okay, when you toss a coin, head is an outcome, tail is an outcome. So here we are going to see outcome and sample space. So a possible result of the random experiment is what is called as an outcome. Let's say you're taking an example of rolling a die. The outcomes of this experiment are 1, 2, 3, 4, 5 or 6. It is not and, it is or. So if we are interested in the number of dots on the upper surface of the die, the set of outcomes can be written in the set format, right? So outcome can be written in the set format. If I put them in the roster form like this, 1, 2, 3, 4, 5, 6. What are all these things? These are all the possible outcomes. And if I put it in a set and give a symbol S to it, then this set of outcomes is what is called as sample space. Guys, are you clear? Are you able to understand what is sample space? So,
Yes, sir.
repeating it again, outcome means the result of an experiment. If you take all the possible results, I'm repeating again, all the possible results and you put it in the form of a set, then that set is what is called as a sample space. That is called as the set of all outcomes. Okay. So each element in the sample space is called as a sample point. In other words, each outcome of the random experiment is also called as a sample point. Is it clear? So our first work is to understand how to write the sample space for different kinds of experiments that we have. Suppose the example one that is there, you have 2 coins, a 1 rupee coin and a 2 rupee coin, are tossed once. If I say find the sample space, what are you going to see? So whether it is a 1 rupee coin or a 2 rupee coin, it has head and tail. This also has a head and tail. Right? When both are tossed simultaneously, how many hits are possible? What are all the possible outcomes? So I'll write it like this: first coin, second coin. You can get a head here, you can get a head here. You can get head here, tail here. Tail, head, tail, tail. Right? So if I have to write the sample space for it, look at the way I'm going to write. It is head, 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 tail, tail, head, tail, tail. So how many possible outcomes are there? It is 4.
4.
It's a random experiment. Suppose I extend this question to 3 points. What will your answer be?
3 heads.
So if I extend the question to 3 points, how many sample points do you think you will have? How many outcomes do you think you will have?
9, sir.
Sorry?
9.
Why 9? Because you did 3 square, right?
Yes, sir.
No, it is the reverse.
2 cube, sir.
2 cube. So how you are going to get this? First, second, third. Okay. You can get a head here, you can get a head here, you can get a head here. Right? You can get head, tail, head. Like this, things can keep changing, right? Are you able to understand? So
Yes.
the simpler way to write for this is, a coin has how many output? One coin has how many outcomes? 2. 2 raised to the power, the number of coins that are tossed will give you the total number of outcomes. So in this case, it will be 2 power 3, that is 8. So when it is 8, divide it with 2. So what you do is, for the first coin, write 4 heads, 4 tails. For the second one, write 2 head, 2 tail, 2 head, 2 tail. For the third one, write head, tail, head, tail, head, tail, head, tail. Are you able to understand this space? So these are all the possible outcomes that you have. So what will the sample space be? So sample space will be equal to head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, 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 all these things. Am I clear, guys? Suppose I extend this to 4 coins, what will your answer be?
16, sir.
It will be 16. Is there anyone having a confusion of how to write? Is there anyone who's not able to understand what I'm trying to say? Is everyone clear?
Yes, sir.
Okay. So when it is 16, how are you supposed to write? For the first coin, how will you start this? When it was 8, 4 heads, 4 tails we wrote. If it is 16, you will write 8 heads, 8 tails, 4 heads, 4 tails, 4 heads, 4 tails. You need to keep writing like that. You guys can try it. If there is a doubt, you can let me know. Okay? This is all about coin. When you get that kind of a problem, I'll explain how to write. Don't worry. Okay. Shall I move on to the next one?
Yes.
So find the sample space associated with an experiment of rolling a pair of dice. One is blue and the other is red. Once. Also find the number of elements of this sample space. So how to write, guys? Tell me, no? So how many outcomes will you have? One die. If you roll one die, how many outcomes are there?
We have 6, sir.
If you roll 2 dice, 6 power 2. You will
36.
36.
have 36 outputs. How you are going to get is first, second. Suppose the first die showing 1, the second die also can show 1. You fix the first number 1, it can show 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Now I have a question. Okay. Here you have 2, 1. Here you have 1, 2. Do they both mean the same?
No, sir.
Why?
Because
Because
one is blue and other is red, so they're different.
one is blue and the other is red. That's right. Okay, and moreover, they are two separate dice. So what is going to be the sample space, guys? 1, 1. Okay. See, try to understand the difference. Here I wrote H without a comma, whereas here I am writing 1, 1 in a bracket because this is an ordered pair. Okay, 1, 1, 1, 2, 1, 3, 1, 4. It keeps on going till what will be the last number, guys? What will be the 36th number? So it
6,
starts with
6.
yes, it will be 6, 6. So from 1, 1 to 6, 6, there will be 36 elements. So 36 elements in the sample space. I hope it is clear. Yes or no?
Clear, sir.
So that's what here it is written. See 1, 1, 1, 2, all these things. Like this, we have 36. Right. Next, we'll go to the other question. So in each of the following experiments, specify the appropriate sample space. A boy has 1 rupee coin, a 2 rupee coin, 5 rupee coin in his pocket. He takes out 2 coins out of his pocket, one after the other. Okay. Similarly, second one is a person is noting down the number of accidents along a busy highway during a year. So how to solve this? A boy has 1 rupee coin, 2 rupee coin, and 5 rupee coin. So each coin is going to have how many outputs?
That's 2 outputs.
1 minute. He takes 2 coins out of his pocket.
What exactly should we find, sir?
You need to find the samples. I'll call it like this, okay? Let's say C1 is the event of taking out 1 rupee coin. C2 is the process of taking a 2 rupee coin. C3 is the process of taking the 5 rupees coin. I hope this point is clear. So all these are events. Events are part of the experiment. Okay, now what is he doing? He has these 3 coins in his pocket. So how many coins does he have in his pocket? He has 3 coins.
3 coins.
So out of the 3 coins, how many coins is he choosing?
2.
Yes. So he's choosing 2 coins. Just a minute. 3 factorial divided. So there should be 3 outcomes. 1 minute. Is taking, yes. This 3P2. It will be 6 outcomes. I'll tell you how it is. Why I wrote 3P2 because why I didn't write 3C2? So when do we use C, guys? When something is
Selecting
select.
something, sir.
Yes. When do we use P? When you are arranging something. Okay. Now read the question clearly. He's putting his hands in his pocket. He's randomly taking out 2 coins. Now comes the important question. Is he taking the 2 coins simultaneously or one after the other? Read the question. No? He takes
One
out 2
after the
coins.
other.
One after the other. So here order is very important. Maybe first time when he takes his hand out of the pocket, he would have got a 1 rupee coin. Okay. Again is putting his hand in his pocket. Again is taking another coin. He might have either got a 3 rupee coin, sorry, a 2 rupees coin or a 5 rupees coin. Right? Are you able to understand? So he could have either got the first coin in the first draw, or he could have got the second coin. Or what is the vice versa? He could have got the second coin first and the first coin next. Does it make sense? Here, C1, C2 is not the same as C2, C1. Guys, are you able to understand? Similarly, he could have got a 2 rupee coin and he could have got a 5 rupee coin. Or he could have got a 5 rupees coin and a 2 rupees coin. What is the other combination that is possible? He could have got C1, C3 or C3, C1. See, if you don't get this idea, also not an issue. If you're able to think in these terms, that is more than sufficient. If you're able to think in the terms that I've written on the left-hand side, that's more than sufficient. So what is going to be the sample space? It will be C1, C2, C2, C1, C2, C3, C3, C2, C1, C3, C3, C2. Guys, does this make sense? Is there anyone having a doubt?
No, sir.
No, sir.
Okay. Next. Second is, what is the sample space? What are all the possible outcomes for a person noting down the number of accidents along a busy highway during a year? So, what could have happened is the sample space. What are all the possibilities? What are all the possible outcomes for the accidents to happen? Is there a count? Is there a fixed limit for it? You can either have a 0 accident, or there might be only 1 accident on that particular day, or 2 accidents. Keep on writing. You don't have a limit. So it's going to be an infinite set because it's an open condition, right? Guys, are you able to understand this? I'm reading it again. A person is noting down the number of accidents along a busy highway and for a duration of how much? Duration of a year. We don't know, right? So let's say he's starting today. Okay, 7th of December 2020. He's trying to write till 7th of December 2021. 7th of December, he is noting down. From morning 9 to night 9, he is noting it down. There are no accidents. According to the record he wants. There might be 0 accidents, there might be 1, there might be 2, there might be 3, or there might be 10 also. There is no fixed number, right? So the number of accidents on a particular day can range from where to where? 0 to any number, which is not known. So that's why the sample space is 0, 1, 2, so on till the end. There is no end for it. If you're clear with this, I'll proceed with the next question.
Clear, sir.
Now see, the example 4 is about, so this question is about a coin being tossed. Okay. So you should always know when you're solving problems based on probability, permutation, combination, this is how you need to think. You first need to understand what is the data that they have given. Second is you need to understand what is the requirement. So a coin is tossed is information, it's a data. So whenever you read that, no, immediately what should run in your mind? A coin is tossed means there is a possibility of head or tail. Okay, what is the next story he's trying to say? If it shows a head, okay, then what is the process he's going to do? Then he's going to follow something subsequently. We draw a ball from a bag consisting of 3 blue and 4 white balls. Okay, that is the process he's going to do when head appears. Suppose if the coin shows a tail, then he will roll a die. Okay, describe the sample space for this experiment. He is not expecting any kind of probability calculation. They are expecting only to write the possible outcomes in a set format. How do I do this? You tell me, guys. So there are 3 blue balls. Okay. So what are all the objects he has in his hand? Coin. A coin consists of a head and a tail. Blue balls. Let's say there are numbers on it. Let me call it as B1, B2, B3. And he has white balls. Let me call it as W1, W2, W3. And he also has a die. It has 1, 2, 3, 4, 5 or 6.
Sir,
Right? Yeah, tell me.
sir, he has 4 white balls. Sir.
Oh, sorry, 4, W4. Now is it fine?
Yes, sir.
Yeah. So for the sample space, what is the order to be followed? Just a minute. So if he is getting a head, then what is he immediately going to do? He will pick a ball. When he picks a ball, it can be ball number 1, or if it is head, then when he is picking a ball, it can be ball 2, head, ball 3, head. When he's picking a ball, it can be white ball number 1, it can be white ball number 2, it can be white ball number 3, or white ball number 4. Similarly, when tail comes, what is he going to do? He is going to roll a die. So he has got a tail. What will be the subsequent step? Rolling a die. When he rolls a die, he can get a 1, T. He can get a 2, T3, T4, T5, T6. Guys, are you able to understand? Yes?
Why T1, T2 till T6, sir? For
Because
T6.
when he gets tail, what is he doing? Look at it. If we chose a tail, we throw a die.
We use the number of possibilities that permitted.
I understand what you're getting confused. It is not T1. This is not the case. Tail, this is from the coin.
One is from the dice, sir.
I didn't write 1 as a suffix. I wrote 1 beside T. This is the way it is written. See. Look at it. No, B1 stands for ball number 1. T1 doesn't stand for tail number 1. T comes from coin, 1 comes from die. I hope it is clear.
Yes, sir.
Okay. Shall I move on? Okay. Consider an experiment in which a coin is tossed repeatedly until a head comes up. Describe the sample space. So it's very simple. So the experiment is about tossing a coin. And when is he going to stop the experiment? As soon as he gets a head. So let's say when he's tossing the coin first time, he gets a hit. He's going to stop the experiment. Okay. Suppose instead of getting a hit, he's getting a tail, then what will happen? He's going to repeat the experiment. When he repeats, if he gets a hit, he's going to stop. Or let's say there is another possibility. If he's throwing for the first time, so this is the first throw, second throw. If the first throw is a tail, then he'll go to the second throw. If the second throw is also a tail, then he'll go to the third throw. Then is a possibility of getting a hit. Then he will stop. Or tail, 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 head. Are you guys able to understand? So like this, the experiment can be repeated any number of times.
Go on till infinity, sir, the sample space.
It is infinite. Yes, it is infinite. So you might have a doubt. When he gets hit in the first attempt itself, why is he not stopping the experiment? This is only a possibility. I'm not saying that this head has surely appeared. If he gets a head in the first attempt itself, he will stop. But not necessarily is going to get a head only. If he gets a tail, he will again toss it till he gets a head. That's the meaning. So it is infinite set. Am I right,
Yes, sir.
guys? Yes. Shall we move on? So a coin is tossed 3 times. A coin is tossed 3 times is the same as tossing 3 different coins at the same time. Coin is tossed 3 times. How many outputs? 2 power 3. What will be the sample space? Head, head, head. Head, head, tail. Head, tail, head. Head, tail, tail. Okay. Tail, head. So I told you the technique. No, 2 power 3 means 4 heads, 4 tails, 2 heads, 2 tails, 2 heads, 2 tails, 1 head, 1 tail, 1 head, 1 tail, 1 head, 1 tail, 1 head, 1 tail. Right? So when you write it like this, you can take them in a proper order and write it THH, THT, TTH, and TTT. Okay, next. A die is thrown 2 times. So how many outputs? 6 square. So when a die is thrown twice, the possible number of outcomes that you get is 36. This also I've showed you, right? You know how to write 1, 1, 1, 2, 1, 3 till 1, 6, 2, 1, 2, 2, 2, 6, 3, 1, 3, 2, so on till 3, 6. Keeps on going till 6, 6. Right? A coin is tossed 4 times. So 4 times means 2 power 4, 16 outputs. Then what are we supposed to do? 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So what I did is, from the number 16, I divided equal number of heads and equal number of tails. This is coin number 1. Coin number 2, what you do is make half of this. 4 heads, 4 tails. 4 heads, 4 tails. Then what will you do? Coin number 3, 2 heads, 2 tails, 2 heads, 2 tails, 2 heads, 2 tails, 2 heads, 2 tails. Coin number 4, head tail, 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 head tail. It keeps on going like this. So I will show you the sample space. It is head, 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 tail, head, head, tail, head. Guys, are you able to understand? If you write it neatly, you will get the sample space. Is there anyone who's not clear? So if you count all the number of sample points, it will be 16. Shall I proceed to the next one? A coin is tossed and a die is thrown. So what will be the sample space? You guys tell me. When a coin is tossed, you might get a head. Once the coin is tossed, a die is rolled. You can get a 1. You can get head 2. You can get head and a 3, head and a 4, head and a 5, head and a 6. Similarly, you can get tail and 1, tail 2, T and 3, T and 4, T and 5, T and 6. Is this clear? So one
Yes.
important note here is, see, when you're dealing with letters like head and tail, you will not write it in an ordered pair format. Whereas if you're dealing with numbers, for example, when 2 dice are rolled, here observe, here I wrote it as 1, 1 within a bracket. I didn't write it as 1, 1 because 1, 1 is 11 actually. Whereas if I write H1, it is understood that head comes from coin and 1 comes from a die. So you will not write it as H, 1. This is not the way we write. When it is alphanumeric, that is when it is a letter and number, we don't write it in the ordered pair format. But if you have 2 numbers, then you should write it in the ordered pair format. Am I clear, guys? Here, if you observe, I didn't write it as H1. This is wrong. I will write it as H and 1. It is understood. Right? Clear? So how to solve this? So we need to write the sample space for this problem. A coin is tossed and then a die is rolled. So when will you roll the die? Only in a case a head is shown on the coin. If it is showing a tail, you will stop it. You will not do anything. So what will be the sample space? If suppose I get a head, then what should I do? A coin is tossed and the die. So I'll roll a die. So what will follow this? Head
Head
1. If I get head, I'll roll a die. I can get 2. I can get H3. I can get H4, H5, H6. Whereas if tail is rolled, if a tail is shown, what will you do? If the coin shows a tail, sorry?
Roll the dice once more till we get one.
No, you will not do. What did they say? It is only 2 activities, okay? So if the coin, they are tossing, a coin is tossed, means the coin is tossed only once. And a die is rolled. That is also only once. Okay. So a die is rolled only when one certain condition is satisfied. If the coin shows head, here the order is important. It is H1, not 1H. Okay. So if tail comes, he will do nothing. He will leave it.
Yeah.
That's it. Got it? So this is the sample space. Right? Next, let's do the sixth one. So 2 boys and 2 girls are in room X, 1 boy and 3 girls in room Y. Specify the sample space for the experiment in which room is selected and then a person is selected. So first, what is the order here? So what is selected first? The experiment is about the room selected and then a person. How many persons are chosen? There is only one person chosen. So if it is room X, okay. So if suppose they have selected room X, then what is the possibility, guys? There are 2 boys. No? So 2 boys means boy 1, boy 2, girl 1, girl 2. Let me take it like this. X means, can I write it as boy 1, comma, X boy 2, X girl 1, X girl 2. Okay. Here let me call this as B3 and let me call these girls as G3, G4, G5. Okay, if room Y is selected, then what can happen? B3 is possible, or Y G3 is possible, Y G4 is possible, Y G5 is possible. Clear?
Yes.
Now let's do the seventh one. So there is one die which is of red color, one of white color, and one of blue color are placed in a bag. One die is selected at random and rolled. Its color and the number on its uppermost face is noted. Describe the sample space. So there is a bag. In this bag, he has one red die, one white die, and one blue die. So what is the experiment all about? First, a die is selected from the bag and it is rolled. Okay. So what is made? What is the note they are making? They are noting down the color and the number on its uppermost face. What will be the sample space? Suppose he is getting a red color, then what can he do? So he takes out red color, then he will roll it. It will be R1, R2, R3, R4, R5, and R6. Suppose he's taking a blue. It will be blue 1, blue 2, blue 3, blue 4, blue 5, blue 6. Suppose he's getting a white. W1, W2, W3, W4, W5, W6. Is it clear, guys?
Yes, sir.
Okay. Next. The eighth one is an experiment consists of recording boy-girl composition of families with 2 children. What is the sample space if you are interested in knowing whether it is a boy or a girl in the order of their births? So the experiment consists of recording boy-girl combination of families with 2 children. So with 2 children, means boy, there is only one boy and one girl. That's what they're saying. No? Or can it be boy-boy also? So what is the sample space if you're interested in the number of girls in the family? Okay. So sample space is, since they told 2 children, it can either be a possibility of 2 boys, 2 girls, 1 boy and 1 girl. So if there are 2 boys, then it is possible that B1 and B2. If it is a boy and a girl, then B1, G2 is possible. One minute. So boy both can be boys, both can be girls, G1, G2. Or 1 girl 2. Okay, what we will do is, instead of taking B1, B2, I will take the combination like this: boy and a boy, boy and a girl, girl and a boy, or girl and a girl. Can you please check how the answer is given at the back? Is anyone checking it? So what is the sample space if you are interested in knowing whether it is a boy or a girl in the order of their births? So it can be boy, 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 girl, girl, boy,
It's correct,
or
sir.
girl. Correct, no? Yeah. Now, what is the sample space if you are interested to know the number of girls in the family? See, when they're saying the number of girls, it can either be 0 girls, or it can be 1 girl, or maximum 2 girls. See, for example, boy, boy, it is 0 girls. Boy, girl, and girl, boy, it is 1 girl. Girl, girl, it is 2 girls. Am I clear with this?
Yes, sir.
Okay. Next. So box contains 1 red and 3 identical white balls. When you say 3 identical, you call it as W. Okay. 2 balls are drawn at random in succession without replacement. Write the sample space for this experiment. So box contains 1 red. So he can get a red ball and white ball number 1. He can get a red ball and white ball number 2. He can get a red ball and white ball number 3.
So I have a
Or,
doubt.
yeah, tell me.
So we can consider it as overall white, right? So since they are all the 3 white balls are identical.
That's what. Then it should be red, white, and white, red. That's it. 3 identical white balls. So identical means is it labeled or not? So how is answer given at the back? Have they given it as RW and WR?
Yes, sir. Given RW, WR, and WW.
No. So since they've used the word identical, it is non-numbered. Okay, so it can be red and a white ball, it can be white and a red ball, or a white and a white ball, because here it is done without replacement. Had it been done with replacement, since this is without replacement, then what could have happened? Had it been with replacement, if suppose the question is like this, then what will be the sample space? You will get red, and there is a possibility for you to get a red again. Guys, does this make sense? Or you can get red and you can get a white, or you can get white and red, or you can get white and white. Are you able to understand the difference between both? This R and R is extra when it is done with replacement. Clear? So next one. There is an experiment which consists of tossing a coin and then tossing it second time if hit occurs. Suppose he gets hit. Okay. Then what will he do? So the data says an experiment consists of tossing a coin and then throwing it second time if head occurs. If he gets a head, what is he going to do? He is going to toss the coin again. Then he can get a head or he can get a head and a tail. Whereas if tail comes in the first attempt, then what will he do? Then a die is rolled once. So he'll get T1, T2, T3, T4, T5, and T6. Guys, is it clear? So this is the sample space. Shall I move on? Suppose 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective and non-defective. Write the sample space of this experiment. So defective, you can treat it like head, non-defective like tail. How many bulbs are chosen? 3, right? So bulb 1, bulb 2, and bulb 3. So when a coin is tossed 3 times, see, I'm just creating a similarity. See, because defective and non-defective are 2 outcomes, and it is like a coin is tossed 3 times. So coin is tossed 3 times, what will you get? You will have 8 outcomes, no? Defective, 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 non, 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 DD, NN, DD, NN, DN, 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 DN. Means the sample space is going to be like this. The first bulb might be defective, second might be defective, and third also might be defective. Or first, second will be defective, third is non-defective. First and third are defective, middle one is non-defective. First one is defective, the remaining 2 might be non-defective. NDD, NDN, NND, and triple N. Clear, guys? So from 12th onwards, you take it as homework, do it. So from the 12th question, you take it as a homework and do it. Tomorrow, I will start with the concept of event, and we will see the types of event. This is a very, very important concept. Suggest you all to concentrate, okay? So practice all these things, because observe here, the operation of sets comes into picture. You should know how to use it, because all these things that you're learning now are basics. All these things will be combined in the miscellaneous part. That is how the questions will be asked. So please be careful and practice. Complete today's exercise. Is there any other doubt?
No doubt, sir.
Just wait for a minute.